My name is Isaiah Morris, and I'm presenting Lab 1 in Steve Millman's class. Okay, so for the first logic gate, I think it's a half adder. You have inputs A and B. You have one bit inputs A and B, and then you have the outputs, which is sum and cry. The first logic gate that you have to go through is an XOR gate where the sum goes through the XOR gate and the carry goes through the A and B gate. The XOR gate outputs one only when the inputs differ, and the AND gate outputs one only when both inputs are one. For the little wave diagram, the waveform shows all input combinations changing over time. When A and B differ, the sum is one. When both are one, uh, the carry on is one. And that correlates to the XOR gate and the AND gate. Mhm. Sorry if you can't see it too close. Um, tried making it like bigger in a way. Okay, for this one, I think you have a 4-bit input in A, I suppose, and then you have a carry on or ink, and then right here you have a screw, and then right here you have outputs cry and Y, and then it's going through the half adder. But the key things that are going on is that I think you have they're called screws or mixers. Not mixers, but screws, something close to that. But yeah. And for the waveform, the output always equals input plus one. Um, and essentially what's going on here? Yeah. Okay, here I think you have the full adder. You have inputs A, B, and then you have the carrion. And you have the outputs sum and count. So for here you have an XOR gate. Um, I think A and B go into the XOR gate, and then for uh, A and B go into the XOR gate, and that's how you get the sum. And for count, you can either go with A and B, or you can go with the carrion, the AND gate, and then you can go with the A and the XOR gate with B. So essentially, the logic gate combines two XOR gates, two AND gates, and one OR gate. Oh, my mistake. Three AND gates, one XOR gate, and one OR gate. And for OR gate, I think if either input is one, the output is one. Yeah, and the waveform, the dark green is zero, stands for zero, and the light green stands for one. Here A is zero until like the 40 ms, and B, so is B until the 20 ms. It is essentially just running a simulation. Uh, here's a little bit tricky. I think you have 4-bit inputs A and B, and then you have the carry on, and then you have the 4-bit outputs. I think count overflow, and then Y. Um, and then here you have, I think, full adders, four full adders, and then here it's an XOR gate, and you have a lot of what was it called? You have splitters. Those are called splitters and mergers. A lot of splitters and mergers that merge the input to different wires uh and merges them to a lot of full adders, which is why there's a lot of circuits going on over there. Here is essentially running the simulation if for 3-bit numbers. No, 4-bit. That's why you have 3030 in the A and B and then 3 on the Y. Yeah, but yeah, that's my presentation. Uh, thank you so much for watching.